Hello BAM and whoever's just watching. This video is to go through equivalent fractions. We've just covered some equivalent fractions in our White Rose maths, so I thought it would be a good idea to go through just the process of doing it because it can be quite tricky, and equivalent fractions is quite a important concept that will help you tackle some harder fractions questions down the road, okay? So if we look at this, this is the first image I want you to see. So this is, I've just outlined, I've already put everything onto this page ready for us to go. So that's why it just looks like a mess of numbers and lines, but we'll focus on each one individually. Okay, so for the core concept is that although they have different denominators, these fractions are going to be equivalent. So they're going to be exactly the same as each other, all right? So each fraction is going to be the same worth as the other, all right? Now, with 1/2, we know that 1/2 would look like this. We would shade in 1/2 of the shape, okay? If we look at the quarters, I've already split this shape into 4 sections. They're not exactly equal on the page, but that is fine. So we can color in 1/4 and 2/4. Okay, so what do you notice about these two shapes now? So if you said that they look exactly the same, or they look almost the same apart from that one looks divided a bit more, you're absolutely spot on. 1/2 has been coloured in. We've coloured in 2/4 and we can see that the same width of the shape has been marked. Okay, so 1/2 is equivalent to 2/4. We will go into how we would do these processes without doing these shapes, but this is just to show you that although 1/2 looks very different to 2/4, they are exactly the same portion of the shape, or portion of the fraction anyway. All right, so I've colored this one into, into eighths, and I've cut this one into quarters, so 8 pieces and 4 pieces here. All right, so I'm going to colour in 2/8, all right? So again, I've coloured in 2/8, and I want it to be equivalent. How much am I going to colour this shape in order to make it match the shape on the left, do you think? Yes, well done, you got it. It's 1/4, all right? Because if we colour this in, again, the same portion of the shape overall has been coloured in if these two are exactly the same. So it'd be 1/4. So the reason why, again, I showed you this is just to show you that these shapes or the fractions are the same even though they look different. The denominator just shows how much this shape has been divided into. They are both worth the same amount, okay? Now, we did a process for tackling these questions. So 1/8 equals how many 16ths? Usually, when you have a question like this, there will be a clear relationship between the denominators or the numerators, okay? So with this one, we know that 8 is, what's the relationship between 8 and 16, do you think? Super job, you got it. 8 doubled equals 16. So we know that we have to multiply the bottom by 2 to get to this. So to change the denominator. All right. Now, if we do this to the bottom, what do we have to do to the top so that they're the same? That's perfect. What you do is you also multiply this by 2. Okay. The reason why you have to multiply both ends by 2 in this case and use the same process, so we're using multiplication for this one, is because when you do something to the bottom to find an equivalent fraction, you have to match it and do the same to the top. So 1 multiplied by 2 equals 2/16, all right? So we're going to try another one here to practice. 3/5 equals how many tenths? 3/5 is equivalent to how many tenths? So again, what you really, really want to look out for are the relationships between the denominators or the numerators on the top. Okay, especially the denominators. So what's the relationship between 10 and 5? Wow, on fire as always. Yes, again, 5 doubled equals 10. So 5 multiplied by 2 equals 10. If we do that to the bottom, we also have to do it to the top. So 3 multiplied by 2 equals 6. Again, this is why practicing your multiplication, your times tables really comes in handy here. Okay, so 3/5 is equivalent to 6/10. So just bear in mind that relationship. All right, 12 and 3. So this number is bigger, and we're trying to get it into a smaller number. We're trying to change it to a smaller number. We're trying to change the denominator into a smaller denominator. So instead of multiplying, we can use a different process when the first number is bigger, or when the first denominator is bigger. What can we do? Yes, well done. We can divide as well. So we're going to be dividing this by something. And again, this is where your knowledge of the inverse and your times tables comes in really handy. What is the relationship by 12 and 3? Can we divide 12 by anything to get 3? Can we divide 12 by an integer to get 3, a whole number? Yes, we can. And that number is perfect. It is 4, okay? So 12 divided by 4 equals 3, all right? So that's how we would do it. We'd also need to put a number here. So your question would probably be something like this as well. So it would be 8/12 equals how many thirds, all right? So 12 divided by 4 equals 3. Your top number here, you're also going to have to divide it by the same. Well done. So if you get a question like that, so 8 divided by 4 equals what? Perfect. 2/3. So that would be your answer to that one. So what you do to the bottom, you also have to do to the top, and vice versa. So sometimes you can be presented with something like this, where you have to work out the denominators, which we will see right now. So a question that you had in your Purple Mash questions was something along the lines of being presented with numerators or denominators, and you had to come up with your own denominators or numerators respectively. So you had to either fill in the top or the bottom numbers of the fraction. So this works exactly the same way. You can pretty much pick any number. So I'm going to say 1/6, okay? So then you look at the relationship between the numerators here. How do I get from 1 to 3? To get from 1 to 3, we know that we can multiply 1 by 3. So we're going to multiply that. If we do that to the top, what do we have to do to the bottom? Yes, we have to do the same thing. So we have to multiply the 6, the denominator 6, by 3 to get this new denominator. All right? So 6 multiplied by 3 is 6, 12, 18. Superstars. Right. So the next one, 2 to 4. I'm going to come up with my own number here as well. I'm going to come up with a, let's do a trickier one. Let's do 2/9. So 2/9 equals 4 what? We do the exact same thing as before. We have to work out the relationship between the numerators in this case because we have the both of them. Okay, how do we get from 2 to 4? We multiply by 2, which means we also have to multiply the denominator by 2 as well. So 9 multiplied by 2 is, excellent, 18. Fantastic, you've all been practicing your times tables, so you can answer this all at home as quick as a flash. All right, now this is one of the trickiest ones that we got. I saw a few people find this one especially devilish to attack and to tackle. All right, so 7 and 14. Okay, so we got sevenths and 14ths as our denominators here. This can throw you off as well because when you're not presented with the denominators or when you're not presented with the numerators after having been done so in the previous questions, it might throw you off a bit, but it's no different. It is no different. You do the exact same thing. So I could put 1/7 here, okay? It's up to you as long as these both work. You could put 2, you could put 3, you could put 7. It's completely up to you. 7 actually might be an easier one. All right, 7 to 14. What is the relationship here between 7 and 14? Yes, again, it is doubling. All right, so 7 multiplied by 2 is 14, which means we have to also multiply, yes, you got it, the top by 2, okay? Sorry, it's a bit crammed in. 1 multiplied by 2 here is 2. So 1/7 equals 2/14. Of course, if you're presented with something like this, we had 7ths and 14ths. One quick way to get rid of one of your options is to say 7/7. We know 7/7 is a whole. How are we going to get a whole for 14? For 14ths? How many 14ths would make a whole? Absolutely right, 14 14ths. So that would always be your equivalent fraction because both of these would equal 1. Because each of these are equivalent to 1 whole. All right, so I hope this hasn't been a bit too complicated. This has just been a bit of practice about how we work out equivalent fractions, okay? If there is anything you're still stuck on, or if you want to tackle some more reasoning questions, then I'm happy to take your comments in the BAM blog, all right? So thank you very much for watching. I hope this redigged your memory of equivalent fractions if you were finding them tricky before. And as I say, I'm always happy to help. So thank you, BAM, and I hope you're staying safe.